Before we begin designing and creating terrains, I first want to go over the different types of terrains that are available. So what we have, if we take a look in the left bar here, is we have a height field terrain and a procedural terrain. The difference of these is a dynamic subdivision. I'm going to add in a standard or height field terrain, and they used to be called standard terrains. So you may catch me every once in a while saying standard terrain. If I say that, I'm actually meaning the height field terrain. So I'm just going to add in a height field terrain, and then I'm also going to add in a procedural terrain right next to it. Now, I'm actually going to have these generate the same geometry and use the same function, and that's one of the new things that's available in Vue 2016. So let's start with the height field terrain. I'm going to double click just to open up the terrain editor. And one thing you'll find if you're not new to Vue is that we now have a graph option for the height field terrain. So essentially what this is we can use the function editor, which was previously only available for procedural terrains, at least the ability to modify them dynamically, or before you'd have to keep applying the function over and over to a 2D terrain. So to make sure that these are identical, and I'm just using basically the defaults, although the vector seed is going to be different in both of them. In other words, it's offset, it's a random generation. I'm going to go ahead and copy the function by right-clicking onto the graph, altitude production, click OK. Then we're going to move over to the procedural terrain, double-click on it, and go to the graph option, and paste the function. And then I'll go ahead and just scale it up. And the overall height of it's going to be a little bit different. We're going to see that the object goes below the ground plane, but essentially we have the same generation, the same terrain geometry being created. With the exception that the height field terrain is a fixed amount of geometry, whereas the procedural terrain is a dynamic subdivision. In other words, the procedural terrain will never run out of detail. The closer you get, the more geometry is created. And then with the height field terrain, you have that fixed amount of geometry that is defined within the terrain editor, and we'll take a look at that in a minute. And I don't know if you saw that, but what I did was I just used the drop object icon over here on the left, which will take the terrain and match it up perfectly to fall onto the ground plane. So I'm just going to do a quick render, and we should be able to see some differences. If not, I'll go ahead and change the fractal to something a little more interesting. So I'm just going to set this, and actually to make this render a little quicker, I'm going to go to the sunlight, turn off the sun softness, and then I'm also going to go to the light and just turn on global ambience, because that'll just render a lot quicker than having to calculate the radiosity. So I'm going to just do a final render this to screen, and we can already see a huge difference between these two terrains. So on the left we have the height field terrain, and on the right the procedural. You can see that the procedural has way more polygons than the height field terrain. And as we move closer into this procedural terrain, it will continually divide the geometry. So I'll do another render, and we'll take a look at the procedural a little closer. And as you can see, we're not getting any polygon look or anything like that, any pixelation, and we have a lot of detail showing up. And now if we move over to the height field terrain and take a look at that, we're going to see that it's very minimal. And you can see that there's essentially no detail on it. And that's because this resolution is fixed. So I'm going to double click on this and open up the terrain editor, and we take a look at the top, we can see that we have 256 by 256. If we turn on the wireframe mode, we can actually take a look at the geometry, and so the polygon amount is going to be 256 times 256, and then multiplied by 2, because it does convert everything to triangles, and we're not working with quads in here. So What we can do though is we can increase the resolution, and it's going to draw from that altitude function. So we can continually add geometry to it, and it will add the necessary detail as we divide. So we can see that the detail is getting higher and higher, and this way you can define a maximum amount of geometry, which does allow Vue to render much faster. And if you want to control the surface primarily with material, so you're getting a nice bump and everything from the material function rather than from the geometry itself, it also allows for easier displacements if you have a fixed amount of geometry rather than trying to displace a procedural terrain, which can take a little bit longer. So we can see that the resolution increase is adding a lot more detail. We no longer have those big smooth sections as we had before. It's still a rather low resolution. You can go up rather high with the terrain resolution, although you typically don't go over 8K. Usually once you get up to 8K, it's no longer necessary to really divide much higher, and it's much easier to just create multiple terrains to cover a certain area. Now, there's advantages and disadvantages to both types of terrains. One really cool thing about the height field terrain, and that's new to Vue 2016, is the height field nodes that are added into the function editor, and these aren't available within the procedural terrain. So we can right-click with the function open, and if you don't have the function editor open, you can right-click on the altitude production and select Edit Function, which will pull up the function graph for the altitude. And if we right-click, we have an option and a pull-down for height field nodes. So these are specific to the height field terrain, and we can add the new erosion nodes. We can also use slope, convexity, blur, terraces, and the auto mapping. Now, the reason these aren't available is because they are post-process effects, and that's why they're not available in the procedural terrain. It's because basically once we generate the geometry, it turns it into an image internally and then runs those height field nodes on top of that. So it uses the image it generates, whereas the procedural terrain, since it's not fixed, it is unable to do that. So if I just show you really quick, we'll go to procedural terrain, go into the function, right click, and you can see those height field nodes are not there. Now you can also see once we're in the procedural terrain that the preview is really low res, and it looks like the fixed terrain we had before, height field, and essentially looks like what we were rendering before. Now this resolution on top is really just a preview, or it controls the material layer. So if we want to increase the resolution of a painted material, or if we're sculpting, doing manual edits on the 2D layer or the 3D layer, this resolution on top is going to control that resolution. So you do want to have a decent size if you're going to be painting materials on it. You don't want it to be too low res, because then it's going to look really blocky, very pixelated. Procedural terrains also have some additional features that aren't available for a height field terrain. One thing is zones, and we're going to take a look at zones a little bit later. And they allow us to basically cut out different parts of the terrain and focus on specific areas of it, either for sculpting or painting or extraction. If we go back to the graph, though, two really cool features that add to the flexibility of the terrain and its quality are the fast shadows option and the quality boost. Now, the fast shadows option, typically I would just leave this on. Most people leave this on because the render times between having it off and on are a big difference. I'm going to go ahead and turn off fast shadows. And a lot of times, too, you don't even notice the difference between these two. What Vue kind of does when the fast shadows option is turned on is it creates the geometry, and then when it renders, it sort of adds a bump map to it so that it doesn't have to calculate all of the shadows for the little tiny bits of geometry that are in there. So tiny little peaks and rocks and stuff. Most of the time they don't really have much of an impact on the shadow that you can really notice, so the fast shadows just kind of renders the lower part of the geometry in a lower subdivision, creates the shadow, and then, like I said, it kind of adds like a bump map to the top of it. I'm going to go ahead and just render this really quick, and we should be able to see some extra details showing. Now, I don't have this whole thing rendered yet, and you can see that it is going pretty slow, especially compared to when the fast shadows is turned on, but it's enough to see the difference. And if we take a look, we can see that the shadows have very fine amounts of details, and we're getting more of a shadow on these little bump areas, which we wouldn't get with the fast shadows option on. But most of the time, it's really not worth the render time in order to get those little bits of detail, because they don't really show up all that much. And if you're doing animation, it's not really worth it at all. So I'm going to go ahead and just cancel that. And if we go back, turn fast shadows on, click OK, and then render it. You can already see how much faster it's rendering. It's a huge difference. Now we have lost a lot of those little tiny details that are showing up. But for the most part, I mean, I think this looks pretty good. And considering the render speed is like 1,000 times faster, at least, a lot of times it's just not worth it. Now, the other option we have that's really cool is the ability to adjust that dynamic subdivision and sort of increase the quality with the quality boost. This way you can get a high resolution without having to have the camera right next to the terrain. Now the easiest way to see this is basically to create, what I'm going to do is create some cubes, or essentially what's going to look like cubes. We'll go ahead, we have a simple fractal, and we're just going to modify that, and we'll use we'll go to distributed patterns, and we'll do square samples 2D. I'm going to get rid of the roughness. Let's see how that looks. And that's still going to be too much, so let's go ahead and change this over to a noise node. So we can select this fractal, change it to a noise, adjust the scale, and see. And we might just need something else. So what I'm going to do is use the noise and change the shape from pyramid, which we can see being distributed, over to cube. And that should give us a neat, almost city-like look. And then we can adjust the amount of samples. We can do 1 sample per cell. So we just get these blocks here. And I'm going to go ahead and keep it like that. And we'll take a look at a render. I'm going to go ahead and scale this down a little bit. And when you have these harsh, sharp edges, it's really a good way to see how the quality boost works. So first we'll just look at with the standard quality. I'm going to rotate this a little so that the sun is a little different. Go open the atmosphere editor, F4, and just raise the pitch. And I'm just going to adjust that a little. And just do a quick render. And actually, that doesn't look too bad without the quality boost on, or increased. I'll go ahead and zoom out a little, because a lot of times you get tearing around those edges, which we can see a little right here. So if we wanted to square those out a little bit more, reduce tearing if there's any, what we can do is increase the quality boost, let's say 1, and then that's going to divide the geometry further and give us a little bit more to work with. And if you look in the lower right corner, you can also see the polygon amount increasing as you increase the quality boost. So right now we got 2.1 million polygons. Let's go ahead and increase that to a quality boost of 13.3. And then increased it by a tiny amount because the camera is farther away. Of course, the closer we get, it's going to increase it a little bit more. But essentially, that's what the quality boost does. It increases the geometry and allows you a way to force it to go beyond the amount that's being generated by where the camera is at. Now, there's one other type of terrain, which is an extension of the procedural terrain, and what it is an infinite terrain. Infinite terrains stretch to the end of the scene based on the height of the camera. They can also be used as planetary terrains. So what we can do is we can load in an infinite terrain by going to the load option over here, which is the other one available. And let's just choose the default. We'll get rid of the ground plane. And it looks like most of it's being cut off. And that, I think, is because the settings here, clip objects under first horizontal plane. So we'll turn that off, and that was just file options. I have a keyboard shortcut, so I just open it up real quick. So under display, you can turn off that clip objects, and that way we can see it below the sea level, because the sea level is going to be used to calculate where that terrain is sitting exactly. So what we can see is this terrain just stretches all the way to the horizon. And as we bring the camera out, what it'll do is add extra geometry and stretch it out to reach the horizon line further. And as you can see, I zoomed out really far, and you can see the current terrain. And then once I let go, it'll increase it larger. Now, right now, it's being clipped because of the OpenGL. But it actually is going in and increasing the overall size. So another thing you can do is if we go back to File Options under Units and Coordinates, we can turn on spherical scenes and planetary terrains if we want these to be spherical. So this is going to turn an infinite terrain into a planetary terrain, which means it's going to be a big round ball. So we have a planet, which means we can zoom out. And one thing you really have to pay attention to is the OpenGL clipping. In the main view, if you need to see a little further, what you can do is go back to the options, and let's see, under display options, right now the OpenGL clipping is set to auto, but we can manually adjust that if we need to see further. And what we can see right now is in the camera view, we're getting much higher in altitude. And we'll see what happens when we go out really far. It's hard to see that terrain right now. So let's go ahead and look down, and then we can see the planet that's being rendered. And then we have the atmosphere on top of that, and then the infinite terrain underneath it. So we could add cloud layers and stuff like that, and make really interesting planets like that. And if we go into the terrain editor, when you're editing an infinite terrain, you won't really get a useful preview. So if you're designing custom terrains that you want to be infinite, the best thing to do is create a procedural terrain and then convert it over into an infinite terrain. So I just cleared out the scene. I'm going to add a procedural terrain double click, and we can set it over to the world mapping mode. And this is going to be part of the world coordinate system rather than being fixed to the size of the object. It's going to move within the world coordinate. So as we move the terrain or side to side or on the what would be the x and y axis, because the z is up, we'll get an entirely different set of geometry. So once we have kind of the overall look established, and a good idea is to make it rather large to begin with. And you can see now it's just adding that detail. It's not scaling up the procedural we had. And you can see too that it's fixed on the current zone. If we delete that zone, we can add a new zone, an entire terrain zone. Now we can see the whole thing. So once we have that set up, we can set it to an infinite terrain, making sure that you are using the world coordinate system, and then that will allow you to stretch that out to the horizon, and that's a good way to kind of design them from scratch. Otherwise, you can use the presets that are available if you go and load in a terrain preset. Terrain presets are not just for infinite terrains. We can get procedural terrains out of it, we can get standard terrains, or height field terrains, and infinite terrains. So they're all part of that terrain file format, which is a PRT file. Alright, so that's pretty much it for the basic differences between the two. We'll explore more in-depth options, and we'll see some more differences between the two as we start to move on through the training.